In this lesson, we are going to solve any stoichiometry problem in a single step for any chemical reaction using bridge technique. Okay, so stoichiometry is related to amount of reactant consumed in any chemical reaction or amount of product produced in any chemical reaction. So before doing any solution of stoichiometry problem, we need to balance out the equation. Why? Because by balancing the equation we get the coefficients which shows the mole ratios of between reactant and the product, and this mole ratio information is crucial to solve any kind of stoichiometry problem related to chemical equation. Okay, so before going to solve the problem, we need to get introduced to some very simple concepts. So for solid substance, suppose for carbon, 1 mole of carbon denotes the molecular weight of carbon, which is 12 gram of carbon. Okay, and if the substance is in gaseous state, we say that 1 mole of any gaseous element such as hydrogen or oxygen or nitrogen, so which corresponds to 22.4 liter volume. So we can either express in gram or in terms of volume. 1 mole of any substance contains Avogadro number of particles, which is 6.02 into 10 to the power 23. So if we know the particle number of any substance, we can easily calculate by dividing with Avogadro number. Okay, and if we have the mole information and we need to calculate the number of particles, we need to multiply that mole information with the Avogadro number to get the particle numbers of that particular substance. By multiplying the mole information with molecular weight, we get the grams, and from grams we can divide with the molecular weight information to get the mole information of that substance. Similar with the volume, the mole information, we can get all these other information, that is grams or liter or the number of particles or vice versa. So this is a very simple problem where it states that aluminum, when it interacts or reacts with oxygen, it produces aluminum oxide. So first step, as I mentioned, let's balance the equation. So by balancing the equation, what information we receive? We receive that 4 mole of aluminum reacts with 3 moles of oxygen to produce 2 moles of alumina or aluminum oxide. So in this word problem, it provides the information of aluminum oxides. 2.3 moles of aluminum oxide is produced. It needs the information of how many moles of aluminum is used to produce this amount of aluminum oxide. So the provided information should be at the extreme left hand of the equation. Okay, 2.3 mole of aluminum oxide. When if we look at this problem closely, there is no conversion needed. All the informations are provided in mole and the mole information is needed. So if we can provide the mole ratio information between reactant and product, we can get the value of aluminum. So we see in the numerator the 2.3 mole of aluminum oxide, but in the equation we see in a standard method 2 mole of aluminum oxide is produced from 4 mole of aluminum. This mole information of aluminum oxide is cancelling each other, only the remaining numbers are there. So if we calculate, we get the 4.6 mole aluminum, the answer. So 4.6 mole aluminum is needed to produce 2.3 mole of aluminum oxide. So it's a very simple problem. As I said that there is no conversion needed. Okay, only using the mole information we are getting the answer. If any equation that needs a conversion, how do we deal with that problem? Here is one of the example. In this case, what it says that H2SO4, that is sulfuric acid, reacts with sodium chloride to produce sodium sulfate. So in this case, gram information is shared. Okay, so we need to convert mole to grams. So let's see how we can proceed. First, we need to write down the equation. Second is to balance the equation. We receive that 1 mole of H2SO4 interacts with 2 mole of sodium chloride to produce 1 mole of sodium sulfate. Okay. The information shared, 30 grams of sodium chloride is used, and we need to know how many grams of sodium sulfate is produced. So the information provided in the word problem should be placed at the extreme left. We know the molecular weight of sodium chloride, right? So which is 58.4 grams of sodium chloride, which means 1 mole of sodium chloride. Okay, so we converted grams to mole. Now from the equation we see that 2 mole of sodium chloride is needed for producing 1 mole of sodium sulfate. And what is the molecular weight of sodium sulfate? The 1 mole of sodium sulfate denotes 142 gram of sodium sulfate, which is the molecular weight. So see, the information which is desired is always on the numerator. Okay, so if we look closely, we see the gram sodium chloride information is getting cancelled out. Not mole numbers, mole NaCl information is getting cancelled out. Mole sodium sulfate information is cancelling out. Only remaining the gram sodium sulfate information. So we have been successfully able to arrange the equation in such a way we are able to solve the problem. 30 by 58.4 by into half multiplied by 142. Okay, if we calculate, we get the final answer. The final answer is 36.4 gram of sodium sulfate. Okay, so 30 grams of sodium chloride when reacts with sulfuric acid, it produces 36.4 grams of sodium sulfate. Now let's proceed to the next question. This equation provides 2 mole of hydrogen reacts with 1 mole of oxygen to produce 2 mole of water molecule. Okay, the information provides that 45.8 liter of hydrogen reacts with how many molecules of oxygen. So now we need to convert liter information to mole information. So the number given should be placed in the extreme left. Hydrogen, and then we already know 22.4 liter hydrogen means 1 mole hydrogen. In this equation it already proves that 2 mole of hydrogen react with 1 mole of oxygen, and 1 mole of oxygen contains Avogadro number. Okay, So now if we calculate the ultimate number, we find that 6.15 into 10 to the power 23 molecules of oxygen needed to react with 45 liter of hydrogen to carry out the water production reaction. We did convert the volume information to mole information, and then we use the mole ratio information from chemical equation, and then we converted that mole information of the particular desired substance to the molecule number information using the Avogadro number, and we can easily thus calculate number of oxygen molecule involved in the reaction. So volume to mole, and then from equation mole to mole, and then molecule number information. So that's how we are calculating the any kind of stoichiometric problem in a single step using the bridge technique, and most of the cases which found to be really easy. So if you have any questions, just drop a comment below in the comment box. I would be happy to answer. Till then, bye.